Alrighty. So this is the Flying Roomba team. Four of us will be Miguel, myself, Mijo, Tam, and Hao. This for the EE Senior Design. So we'll briefly be talking over the Flying Roomba and what it's all about. So the objective is overall is to optimize the Roomba to clean multiple floors. Usually Roombas in general only clean one floor and are limited to that unless the user itself carries it and puts it in the second floor. So our job is to make it autonomous, basically clean the first floor, fly up the stairs, and then start proceeding with its cleaning process on cleaning the second floor. So our approach to this was just approaching it as a normal drone, and then just adding the flight system to the Roomba attachment. So our stuff will be using is the ESC power distributor, ducted fans that is clockwise and counterclockwise, and it will be an even number. This will help to stabilize the overall system. We'll be using camera for detection, a Raspberry Pi, which is the computer companion, Pixar, which flight controller, and DC regular and a LiPo battery. So overall background, we're basically the first ones to do it. There is a YouTube video where Peter Seipel, which is an engineer and YouTuber, he made it a manual Roomba. Although he wasn't successful as much, it was really unstable and it was manual control. Our job is to make it autonomous and fully functional. So this one will be having is just same process, cleaning multiple floors. So experimental setup. So the basic idea is for Roomba to, so this is basically the overall idea is to clean the first floor for an X amount of time, move towards the stairs location. This will be using the Seek Dock feature, and then it'll switch into flight mode, which will use the camera based on the stairs detection to navigate up the stairs, and then finally land on the second floor and proceed doing cleaning operations. So although the idea is pretty simple and straightforward, the software part takes a lot of work to do, I guess. So the initial setup will constitute with flying Roomba manually first, so we can do analysis and calibrations in order for it to actually stabilize while in air. And then finally, we'll just apply the autonomous part. We'll modify to be fully autonomous, recognize the stairs using the camera, which uses CNN convolution, fly up the stairs, downstairs constraints. Because of its size, it'll be limited to small areas, so it'll mostly clean larger areas, and it won't be able to clean edges.
For the test plan, is experimental. We have two parts, that hardware and software. For the hardware part, the first one we tried with the 4-motor, but it's not able to fly because it's the battery too heavy. And we try to 6-motor as the block diagram, and it can fly up so far. For the Roomba part, we give it the command control to go to the dock station. And for the software part, we use the CNN to train the staircase before, but it doesn't work on that. So we switch to the YOLO V5 for the training, and we able to detect the stair. For the experimental results, as you can see, the Roomba able to fly with the manual control, and the camera able to detect the staircase. However, we can work to hardware and software part able to work separately, and we're not able to stick them together yet because We didn't know that we need the sensor to know the localization. And you can see on right here, this is the final hardware we have with the SIG motor. And this and in this figure is this is a manual takeoff we test so far. And this is our staircase detection using the camera, and it can show the confidence percent, label, distance, and the angle based on the staircase, the basting box. For the conclusion, we adjust our goal so far with the hardware part and the software part. However, we need to communicate, put them all together to make it fly up to the stair. So to do that, we will use the Raspberry Pi to communicate between the Pixhawks and the Roomba. And